Today we're going to take a look at density curves and in particular normal curves in standard distribution. A density curve is a mathematical model for the distribution of our data, which is always on or above the horizontal axis, and the area underneath our curve is always 1 or 100% of our data. Now here's a couple of examples of normal Gaussian distributions. The area underneath this red curve has an area of 1. The middle of this curve is your mean. Well, same idea over here. Area underneath this curve is 1. Notice since it's a taller curve, it can't be as wide for your area to be 1. Also in the middle of your curve is your mean. Now, if you are really interested in how to graph this on your calculator, you could. Here's your formula. It's 1 over the square root of 2 pi times e. E is your natural number e on your calculator, raised to the power of negative 1/2, and then x minus your mean over your standard deviation, all squared as an exponent. Don't be real concerned about that though, but just be familiar with the basic shape of a normal density curve. Here's an example of 3 different curves where we have the same mean of 15, because 15 is in the exact center, and a standard deviation of 2, of 4, and of 6. The larger the standard deviation, the wider the curve. And since it's wider, it can't be nearly as tall for your area to end up being 1. Down here we have a family of 3 curves where they have the same standard deviation. Hence, they all have the same shape. However, your means are different. Here on the blue one, we have a mean of 10, and then we have a mean of 15, and now we have a mean of 20. So if your mean is different, all it does is just move it left and right on your horizontal axes. However, if your standard deviation is different, it makes the graph wider or narrower. Here we have a standard normal curve, in this case with a mean of 0 and a standard deviation of 1. And that's what we have over here on the right. If your mean is 0, standard deviation of 1, when it's a normal curve, 68% of your data is within 1 standard deviation in each side of your mean. If you go 1, 2 standard deviations to the right and 1, 2 standard deviations to the left, 95% of your data is always within 1 standard deviation of your mean. If you happen to go 3 standard deviations to the right and to the left, 99.7% of your data is always within 3 standard deviations of your mean. On the left, the same thing works, but here we're dealing with a mean of 64.5 inches and a standard deviation of 2.5. So if you go 2.5 units to the right, which is 1 standard deviation to the right, and 1 standard deviation to the left of your mean, that's 68% of your data. 2 standard deviations to the right, 2 standard deviations left, that's 95% of your data. 3 standard deviations in each side is 99.7% of your data. If you're dealing with normal distribution, that's always the way it is. It always follows that 68, 95, 99.7 rule. So go ahead and answer this question. The mean is always greater than the median is false here, because your mean and your median are always going to be the same on a normal standard curve. Your mean or your standard normal curve is always symmetric, it's always bell-shaped, always has one peak. Okay, which one of these would have a mean of 0 and a standard deviation of 3? Well, you see they both have a mean of 0. Question is, which one would have the standard deviation of 3? Is that this one here, where 3 ends up being approximately here? And here, so which one of these would have a standard deviation of 3? In this particular case, it would be the second one here. Where your curve switches from kind of going concave down here, like a parabola going down, to part of a parabola going up, when it switches from going down to going up, that's always one standard deviation. So you can always use that idea to help you out. So let's take a look at the next one here. You'll notice that 7,000 and 9,000 is 1,000 on each side of this. In other words, it's one standard deviation on each side of your mean. One standard deviation on each side of your mean, according to the 68, 95, 99.7 rule, is always 68% of your data. Let's talk about z-scores. A z-score basically tells you how many standard deviations you are on each side of your mean. The formula for your z-score is always going to be your data value minus your mean over your standard deviation. If your data value is larger than your mean, then your z-score is positive. If your data value is smaller than your mean, then your data value is negative. So let's go ahead here and look at this particular problem. We have women's heights, mean of 64.5, standard deviation of 2.5 inches. We want to know what percent of women are shorter than 67 inches. That's 5 feet 7 inches. So in other words, here's your 64.5. We go to 67, which would be to the right, by 2.5 inches. We want to know what percent of women are in this white area. So in other words, we want to know the area of that white region. Well, to do that, we got to go ahead and figure out our z-score. You take your data value, which is 67, minus your mean, which is the 64.5, over your standard deviation, which is the 2.5. We get 2.5 over 2.5, which is a standard deviation, or simplifies down to 1. So in other words, it's one standard deviation to the right. However, it's not the 68 that we talked about before, because that would be if you were one standard deviation to the right, which we are, and only one standard deviation to the left, but we're not. We're going all the way to the left. So this basically boils down to the following. If you were one, excuse me here, sorry about that. If you were one standard deviation on, on each side, you know that this center part here is 68. However, we also need to go ahead then and include this tail here. Well, if both tails end up, or if the center is 68, you know both tails together then is 32. If this tail here and this tail over here and add up to be 32, and they're both the same size, you know that this would have to be 16. So your total area of the white then is your 68 plus your 16. So in other words, you're taking your 68 and then you're figuring out what's in the tails, and that's the 1 minus the 68, and that's where the 32 came from. Since they're both the same, we got to take half of it or divide by 2 to get only one of them. And that's where we get that 16. So it's 68 plus 16, which is 0.84 or 84%.